Hey guys, I want to keep working with domains and square roots. So I want to start off with the function f of x is equal to the square root of x, and then the function g of x is equal to x minus 3. Now let's start and let's find f composed with g of x. Now f composed with g of x is where we take g and we insert it into the value of x in f of x. In this case, g is x minus 3, and f of x says take the square root of it, so we're going to take the square root of g, and we will get f composed with g of x, square root of the quantity x minus 3. Next, I want to take and find g composed with f of x. I'm going to take f of x, which is the square root of x, and I'm going to apply g to it. G says subtract 3. So I'm going to take the square root of x, and I'm going to subtract 3 from it. And I get g composed with f of x, square root of x minus 3. And the difference between the two of them is the order of operations. That's the difference between the two. But let's look at their domains. For f composed with g, the domain x minus 3 has to be greater than or equal to 0, which means that x has to be greater than or equal to 3. So the domain here is equal to, let's see here, 3, square that off, to infinity. Whereas over here in g composed with f, this, the square root of x has to be greater than 0. It can be equal to 0. So that means that our domain is going to be 0, infinity. So we have two different compositions with two different orders and two different domains. And the difference in the domains is because of the difference in those orders. Let's take a look at another complicated composition and domain question. For this one, I want to look at the rational functions. F of x is equal to, let's make this 3 over x plus 4, and g of x is going to be equal to 1 over x minus 1. Okay, now right away for f of x, let's take a look and let's note that x cannot be negative 4. And for g of x, let's take a look and note that x cannot be 1. Right away. And then let's find f composed with g of x. That's going to be 3 over 1 over x minus 1 plus 4, which is really kind of an irritating expression to work with. So this would be, let's see here, 1 plus 4x minus 4 over x minus 1 over 3. So that's 3 divided by 4x minus 3 over x minus 1. That's 3x minus 3 over 4x minus 3. X cannot be 3/4. We're going to do the same sort of composition thing here for g of x. And notice again what I'm going to do. I'm going to do g composed with f of x, and that's going to be equal to, okay, on top of g is 1. And g of x is minus 1. So there's my minus 1. Now I'm going to take f. And what's f? Right here. So this is 3 divided by x plus 4. But this is kind of hard to simplify. 3 over x plus 4 minus 1. So I'm going to take this minus 1. I'm going to rewrite it as 1 times x plus 4. So that's minus x plus 4 over x plus 4. Just like over here, we take this and we rewrite it as 4 times x minus 1 over x minus 1. We rewrite it as 4x minus 4 over x minus 1. which is where this 4x minus 4 came from. Okay. So, we do better than that. Draw a line, 1 on the top, 3 over x plus 4 in the denominator. 3 minus 4 is 1, so this is minus x minus 1 over x plus 4. And all of that is beneath a 1, just like all this over here was beneath the 3. Now, I'm going to take this 1, I'm going to treat it as 1 over 1, divided by minus x minus 1 over x plus 4. That's 1 over 1 times x plus 4 over minus x minus 1. That's x plus 4 over minus x minus 1. X can't be 1. And over here we did the same thing. We took and we wrote this as 3 over 1 times denominator, numerator, right? We took and we flipped this to do the division. We write it as its reciprocal. And then 3 times x is 3x. 3 times 1 is minus 3. So that's 3x minus 3 over 4x minus 3. And we find the values that are excluded from the domain. No joke, those are involved and those are tough. What if f of x was equal to 1 over x plus 2 and g of x was x over x plus 1, and I'm looking to find g composed with f of x? This would be ugly. My numerator would be 1 over x plus 2. My denominator would be 1 over x plus 2 plus 1. I'm going to change 1. I'm going to change 1 to be x plus 2 over x plus 2, because that way I can add it to 1 over x plus 2. This numerator adds together and gives me x plus 3. So we have 1 divided by x plus 2 divided by the quantity x plus 3 over x plus 2. Oh my goodness. That's 1 over x plus 2 divided by x plus 3 over x plus 2. And now we replace this with its reciprocal, right? We flip the fraction to get x plus 2 over x plus 3. We're going to multiply. Now these are actually going to reduce out. So we'll get 1 over x plus 3. Wow. And that's our final composition. And I would say that the domain would be, so your x can't be negative 1. X can't be negative 1. It can't be negative 2. It can't be negative 3. So I would say that the domain is negative infinity to negative 3 unioned with negative 3 to negative 2 unioned with negative 2 to negative 1 unioned with negative 1 to infinity. That would be the domain of this function with these 1, 2, 3 holes in it. Alright. Great. I'll see you next time.